This is a question in solid geometry, volume and areas. A wooden toy is in the shape of a cone mounted on a cylinder, something like this. If the height of the cone is 24 centimeter, the total height of the toy is 60 centimeter, and the radius of the base of the cone is twice the radius of the base of the cylinder, which is 10 centimeter. Find the total surface area of the toy. Okay, let me copy this picture here. I'll try it if I can expand this. Yeah, that's good. So this is a cone mounted on a cylinder as shown here. If the height of the cone is 24 centimeter, so this height is 24 centimeter. The total height of the toy is 60 centimeter. So which means the height of cylinder would be 60 minus 24, which is 36 centimeters. So the height of the cylinder it's always good to write the dimensions on the picture so it makes our thought process more clear. So the height of the cylinder is 36 centimeter. That's because the total height of the toy is 60. So 36 plus 24 is 60. And the radius of the base of the cone, so we are talking about this radius. This radius. So radius of the base of the cone is twice the radius of the base of cylinder. So if this is R, that one would be 2R. So the radius of the base of the cone is twice the radius of the base of the cylinder, which is 10 centimeter. So the radius of the base of the cone seems to be 10 centimeter because it is said that the radius, we need to follow the English here carefully. The radius of the base of the cone. So we are talking of the radius of the base of the cone is equal to 10 centimeter. It is another fact that this radius, which is 10 centimeter of the cone, is twice the radius of the base of cylinder. So the radius of cone is 10 centimeter. So I'll just write this one as 10. And this one as 5 centimeter. So we need to find the total surface area of the toy. So if we notice carefully, if we draw the side view, it will look something like this. So this is the cone on the top. Now let's draw the cylinder at the bottom. Sorry, it's not the cylinder. So this is the cylinder at the bottom. So this will look something like this. This is the toy. Now, if we notice, we want to calculate the surface area total. The cylinder, we have the curved surface area and also just one flat surface area. The other flat surface area is gone because it merges with the cone up. So we have one curved surface area. We have one flat area. For the cone, we have the total curved surface area, which is pi RL. However, the base is not complete. The base, the pi r square is not complete because part of it, the middle part, merges with the cylinder. So we have to treat that appropriately. So I'll just show the missing. This one should not be accounted for, neither for the cone nor for the cylinder. So actually, if this cone and cylinder were separate, this shaded area, so I'll just paint this. The shaded area, the circular area, would have been accounted twice because it is part of the cone, the middle part of the cone base, as well as one flat surface of the cylinder. So this would have been accounted twice had the cone and the cylinder be had the cone and cylinder been separate. If these were something like this, so we would have accounted for this as well as the middle part had they been separate, but they are merged together. So two times the flat surface area of the cylinder have to be omitted. So if you can imagine that way, we need to calculate the total surface area of the cone plus total surface area of the cylinder minus 2 times the surface area of this shaded region. So we can directly either do that or treat it this way, the way it is. So I'll just write the formula. So the curved surface area of the cone is pi RL. This is pi RL. And this is 2 pi RH. 2 pi RH. That's the curved surface area of the cylinder. We all also have one side of the cylinder, one flat surface, which is pi r square. So I'm just writing the formulas. The other pi r square is missing. The other side of the pi r square is missing. And this is also an empty area in the base of the cone. So this is pi r square, which is the base of the cone, minus pi r square, which is the flat surface area of the cylinder. So I'll just write the cone radius as capital R, just for the sake of clarity. So I'll just repeat. The curved surface area of the cone is pi RL. The flat surface area of the cone is pi r square, which is the total area of, so I'm talking about this total area of the base, minus pi small r square, because this area is not exposed, so we should not be accounting for. Curved surface area of the cylinder is 2 pi r h, and the flat surface area, there are two flat surface area, out of which only one is exposed to the outer environment, which is pi small r square. So pi r square, 2 pi r h, pi r l, and pi r square minus pi r square. So we need to add up all of these. So if we add up all of these, we will be cancelling the small pi r square. So go pi r square minus pi r square. This gets cancelled. So what remains is area, total area of the toy, area of toy. So which is the exposed surface area of the toy is pi into RL. So I'm just adding up all these areas. RL plus R square so pi RL plus pi R square plus 2RH, which is of the cylinder. So just to recap, pi RL is the curved surface area of the cone. Pi capital R square is the total area of the base, minus, so we just account for the thing which is not exposed, is pi R square. Pi capital R square minus pi small r square. 2 pi RH is the curved surface area of the cylinder, and pi small r square is the area of one flat surface area of the cylinder. So if we add up all of these, pi r square and minus pi r square get cancelled. So we have pi RL, pi r square, and 2 pi small rh. So pi capital RL, this is for the curved area of the cone, pi r square, which is the base of the cone, plus 2 pi rh, 2 pi rh, which is the curved area of this cylinder. So they say we need to take the pi as 3.14. Before that, what is L? Hmm? Because if we take in this cone, oops, sorry. In this cone, if we take half the cone, it will look something like this. And out of that, this one is L. So this is a slanted length. How do we calculate L? So we already know the radius, which is 10. So this is actually a right triangle and the height is 24. 24. So this is a Pythagorean triplet, 24, 10, and 25, but let me just verify that in my calculator. So 10 square is 100 and 24 square, let me check, is 576. So here, this would be, the L would be L equal to square root of 24 square, which is 576, plus 10 square, which is 100. So what is square root of 676? It is 26. It's not 25, it's 26. So the L is equal to 26 because this is a Pythagorean triplet. So if one leg is 10, the other leg is 24, the hypotenuse would be 26. So we based on the Pythagoras theorem. So I'll just say is equal to 26. Is equal to 26. So we got L as already. So if we write, so the area of toy is 3.14 multiplied by RL. R into L is 10 into 26, which is 260, plus R square, capital R square, which is 100, because 10 square is 100, plus 2 into small r, which is 5, into h, height of the cylinder, which is 36. So this is equal to 3.14 into 260 plus, so I would say I'll just add up 260 and 100 and write 360 plus 360. 2 5s are 10. 10 into 36 is 360. Which is equal to 3.14 into 720. 360 plus 360 is 720. So now 3.14 into 720, we can just calculate easily. 3.14 into 720 would be 2260.8. 2260.8 square centimeter. This is the answer. I'll just write answer. So 3.14 into 720 would be 2260.8. I'm sorry, it's not 0.6, it's actually 0.8. Which is equal to 2260.8 square centimeter. This is the answer. So 2260.8 square centimeter. So in any problem of finding the areas or the volumes, it is important to draw the picture and put all the dimensions here and then do some critical thinking, which areas are exposed to the air and which are not, and the answer will be clear. Thank you.